This year's freshman imaging project is to create a system that can aid the RIT hockey team by gathering and analyzing statistics of players to improve the overall team performance. Our system captures real-time footage of games and practices, which are then run through a neural net that tracks, identifies, and produces statistics of the players. These statistics will allow the coaches to analyze their players' strengths and weaknesses so they can adjust their roster and practices to maximize the team's success.
We use a neural net called a NASNet, which is trained on thousands, if not millions, of images. Those images are then utilized for training of the neural net, and it generates the markings of what a person looks like. From that model of what a person looks like, we can feed it into our own data, and we generate XY coordinates on the image. We then do a homeographic transform of the image onto a bird's eye view of the rink, which allows us to track each player around the rink and do analytics on it.
Once the player's location is known within the frame, we need to calculate their location on the ice. We accomplish this by using a homographic transformation, which uses a transformation matrix to warp the image so the oblique angle looks as if it's a top-down angle.
So what our particular system does is it takes goals and it figures out where they enter the goal plane, and we're going to take all of that information and make a heat map, so our end product will be able to see where the goalie lets in shots most frequently, which will be helpful for the goalie coach so we can identify where the goalie's weak areas are in the plane of the net.
So for the hardware side of the Goalie System, we had 2 cameras that we installed at the ice rink. We had one behind the net, and then we had one over the net, which we installed before the season started. They'd be on a buffer, they'd always be recording, and whenever a red light would go off, since a goal is scored, they would record to memory what the cameras just recorded, so that the goal would be captured in the recording on the computer. And then we take this data of the 2 feeds of the goal and then bring it back and use it in the programs that Gail mentioned to create the analytics that we need for the final product.
At the event processing group, we get information from the image analysis group as to the XY coordinates of each player on the rink throughout the game. And we also get information from the goalie group about where the puck enters the RIT goal. And then using those 2 major points of data, we run it through a series of different codes, and it tells us how long the RIT players spend in each zone. We also can determine where the puck enters the goal and create a heat map of that. We can track the players leading up to a goal scored and create a heat map of where they scored from on the ice, and do different kinds of visualizations with animations.